Hi there. This is another video of me solving random code problems. So let's begin. There's an interactive graph with n node where each node is a number from 0 to n minus 1. Okay. You're given a 2D graph where graph of U is an array of node that node U is adjacent to. So this is an adjacency list, right? So we have like index of 0, 1, 2, 3, right? Represent the node. So n is like the length of the graph. So we have like node 0 here, right? We have 1, 2, 3, right? We just can access 1, 2, and 3 here, right? So on and so forth. Okay. Um, there's no self edge, right? Which is the node cannot point to itself. And there's no parallel edge, right? Which is something like this. It is only one way. Sorry. And then if V is in graph U, then U is in graph V, right? So 0 can go to 1, and 1 can go to 0. Like it's both way. If it is not directed, right, then only 0 can go to 1, 1 can go to 0. But it is undirected, so we can go both way. Okay. A graph is bipartite if the node can be partitioned into two independent set A and B, such that every edge in the graph connect a node in set A to a node in set B. So two independent sets A and B, such that every edge in the graph connects every edge 1, 2, 3, 4, 5, connect a node in set A and a node in set B. So look at this edge, right? Uh, so for example, if 0 is in A, right, then 1 has to be in B, right? Because the edge here has to connect one node from set A and one node from set B, and vice versa, right? If A is 1, sorry, if 0 is in A, then 1 has to be in B, right? And if 1 is in A, then 0 has to be in B, right? Doesn't matter. And then this edge, right, 1 and 2, 1 is already here. So 2 must be here, right? The edge has to connect one node from each set. Same for here, 0 and 3, right? 0 is already here, so 3 has to be here, right? One node from each set, right? Did edge 2 and 3, right? Already valid. 0 and 2, right? 0 is not like in here, 2 is also like not in this not connecting anything. They are in the same set, so this is not valid. So we have false here, right? If you look at the second example, so we have like 0, 0 and 1, right? 0 and 1, right? And then 1 and 2, 1 is already here, so 2 has to be here, right? Right, 2 and 3, right? 2 is already here, so 3 has to be here, right? 3, 3, right? One node from each set, 0 and 3, which is already valid, right? So we return true. Yeah. So the whole point is here just that if a node is in set A, then the neighbors, right, has to be in the opposite set B, and vice versa, right? So we can iterate through each node, right? We can assign the first node to set A or B. That doesn't like really matters, right? So let's say 0 is in set A, right? 0 is not in the hash map. In this, let's call this one node to a set, right? So a node is belonging to a set. The node is not in the set, in a node to set in the hash map. So we add the node into the hash map and assign it a set, right? Set A. So after we finish, what do? We look at its neighbors, right? Neighbors. So 1 and 3, right? Okay. So 1, what is 1? Uh, 1 is not in the set, right? In the so we 1 doesn't have a set yet, so we give it a set, and it has to be the opposite of A, right? So B, right? Same for 3, that be B, right? And we look at the number 2 here, right? Sorry, we 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 have process 0 and the neighbor 1 and 3, right? So we look at node 1 now, right? So we are at node 1. What do? We look at the neighbors, right? Which is node 0 and node 2. Node 2 is not in the set, so we add 2 in here, right? Remember, the 1 is B, right? So 2 has to be in the opposite set, so A, right? And the second neighbor is 0, right? 0 is already in the 0 is already have a set assigned to it. So we compare the set that 0 belongs to, right? Is this set the opposite of the set of node 1, right? So A is opposite of B. So that is correct, right? And we just keep doing the same thing for every single node. We look at the node, right? And then we process the node. If the node is already in if the node is already in the set, then we just compare the set that the node is assigned to our expected set, right? And then we just keep doing the same thing for its neighbor, right? And every time we go down a level, we will toggle the set, right? A to B, B to A, so on and so forth, right? If I look at B here, right? If we go from A, right, and we go to the neighbors 1, then the current set now has to be B, right? The current set, right? This is our current set. When we go from 0 to 1, you need to toggle the set from A to B, right? And if 1 is already have a set assigned to it, then we just compare, right? Okay, um, it is our expected set, right? Is the expected set for 1 equal to the set that 1 is in, that 1 is assigned to, right? If they are equal, we are good. If they are not, we return false. We short circuiting and return false, right? So the time complexity would be B plus E. B is the total number of nodes, and E is the total number of edges, right? It is not V times E, right? Even though we need to, it seems like we need to process even though it seems like we need to look at the neighbors of every single node, but no, if it is already in the hash map, then we're just gonna re return, right, the expected value if the set here is equal to the expected set, right? If it is not in the set, then we look at the neighbors, the edge. So it is V plus E. Okay, so let's code this up. Okay, so what do we want to do? We want to iterate to the node, right? Okay. We want to and then also let's see, the graph. Okay, another thing I forgot to mention, the graph may not be connected, which means like it would be a number 4 out here, right? For example, so we need to iterate through every single node because it might not be connected to other node in the graph, right? So if the graph is connected, we don't even need a policy. We can just like run the default search rate on it. Um, but in this case, we need to actually iterate through every single node. And then what do we want to do? We only want to process the node if it has not yet been processed, right? So we have the num2 index, remember? Num2 stack, is an empty hash map. So if node, right, not, if node is not in the num2 stack, then we want to process it, right? And then by or type equal to the BFS of the current node. And we need to start from a set, right? We can start from set A or set B, that doesn't matter. So I'm gonna start from set A. So set A, set B, set B, right? If it's not bipartite, then we return false, right? Otherwise, we return true. This is our structure here. And we need to create a DFS function for the node and the current step, right? So if the node is already in the num2 set, right? If the node is already have a set assigned to it, right? Then we want to compare. If the set belong to that the node is being assigned to is equal to our expected set, right? So our expected set would be the current set, right? Okay. And then if it is not yet in our num2 set, right? If the node doesn't have a set yet, then we give it a set, right? Node equal to the set. What is the set? Which is the current set. Okay. And what do we want to do? We want to look at the neighbors. The neighbors equal to the graph of node. We're going to do this adjacency list. And we want to toggle the set, right? So the next step. So if the current set is equal to set A, we return set B. Otherwise, we return set A. Right. Right, because the neighbors of the current node have to be in the opposite set of the current node, right? Because the edge have to contain one node from each set. Okay, so we iterate over the neighbors, neighbors line plus plus, right? And if and what we want to what do we want to do? We want to run the depth search on each neighbors, right? Parking in the current neighbors, and then the next set, right? So if it is not bipartite, we return false, right? And otherwise we return string. All right, let's give it a try. Okay, accepted. The space complexity would be over V, right? Because we need to store in the worst case every single node in the hash map here, right? So again, if the node is already have a set, right? We just compare, okay, is that set equal to our expected set, right? If it is, it's true, we just return true, right? If it's not in the set, we give it a set and then look at the neighbors, right? And the neighbor had to have a opposite set. You know, at any time, if we found an invalid edge, we just short circuit and return false. Okay? If we return false here, then we will return false here. If we iterating to every single node, right, and we don't return false, which means every edge is valid, so we return true here, right? And remember that if the edge is connected, right, we don't even need a for loop here. We can just run like the depth first search, because eventually we will be able to reach every single node, right? But it's not connected, so we need to follow here. We need to actually look at every single node. Submit, and thank you for watching.